Okay, so in this video we're going to look at a basic use of this class TreeMap in Java. Again, we need to import the java.util package. You can put dot star, and I declare a tree map, say tmap a equals new tree map. So this is the name of the object. Now the tree map is a two-dimensional data structure, so it can store things as a key value pair. Now the key values have to be unique. So if you try to add more than one entry the same key value, it's going to overwrite the previous record with the same key value. So in this case, the first entries are the keys like 10, 4, 7, 5. So they have to be unique. And the values could be anything. It could be a string like this. It could be another integer. It could be even a vector, as we'll see in another example. So it could be anything. And it need not be unique. So you could even have ABC for the second record. Okay. So it need not be unique. Only the key values have to be unique. Now, so I put tmap a dot put 10, then abc, then for 4 pqr and so on. So I print the contents of the tree map a. So it's going to print the key and the value pairs, and I can check whether a particular record with a key of a value exists or not. So I can say tmap a dot contains key of 2. So 2 is an integer, and we check whether there's a record with key 2, and in this TreeMap there's nothing such like that. So tmap a dot contains key of 2 is going to return false, and not of false is again true. So we are going to have an output saying TreeMap a does not have 2. Now we know it has 4 in it, so I can check tmap a dot contains key of 4, and it's going to return true. So I can say and go inside the if statement and say tmap a dot get of 4. So this is going to return again an object of class object, because that's how internally all this value is going to be stored as an object of class superclass object. So when you retrieve it, it has to be typecast to whatever the object we know it is of type. So this is of type string, so we need to typecast it to string and print that value here. Now, as I said, you could rewrite the contents of with a particular record by just saying tmap a dot put of the same key value, say 4, and some other value. So it's going to overwrite what was the value for 4 before, which is pqr with omn. You can write it with uvw if you want to. So as I said, the values need not be unique. It's the key that needs to be unique. So I can say tmap a dot contains key of 4. Again, it contains the key still. So it's going to go inside, and after the replacement, it's going to print what's the value. Okay. So this 7 is not going to be affected. So we can print the contents of the tree map in total after the replacement. So let me run it now. Okay, let me compile and then we'll run it. Okay, so the contents of the tree map A are, now again, one thing about tree map is, even though we are putting the things in this order, the key records in this order of the key values 10, 4, 7, 5, internally the record will be, the tree map will be sorted in the increasing order of the key. So the smallest among these integer values is 4, so it's going to print, store it as 4 pqr as the first entry or the first record, then 5 def is the second record, then 7 uvw is the third one, and 10 abc is the last one. Now it is going to check for 2, and it says it does not have 2, and the value for record 4 is pqr initially. Then we overwrite that with uvw. So after the replacement, it's going to have uvw as a value. So again, when you try to print the contents of the tree map after the replacement, it's going to have same 4, 5, 7, 10, but with the value for 4 now being uvw, 5 is still def, 7 is still uvw, and 10 again abc. Okay, So with that we stop.